Hey guys, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 3 from chapter 4, which is talking about solving quadratic equations by completing the square. Now, we learned how to complete the square for quadratic functions in chapter 3, and we're going to apply some of this knowledge to quadratic equations. Now, because we're dealing with quadratic equations, our process or technique is going to be a little bit different than what we would have done for quadratic functions. But for the most part, it follows the same sort of rules. So to explain the little steps here, we're going to show it using an example. And this one here is actually example number 2 from your notes. So our first step in completing the square is to move the c value to the right side of the equation. So here we have a quadratic function or equation in standard form, and we need to move this value to the other side. Now, in order to move it to the other side, you have to do that opposite operation. So you subtract 32 on each side. So what we'd be left with is a squared plus 18a is equal to negative 32. Step number 2 is to pull out a common factor of a from the left side. So in standard form, we have ax squared plus bx plus c. That'll be the number that's connected to your x squared term. In this case, we do not have an a value. I know it's a little bit strange with your variables here, but here we do not have an a value. We would assume it's just 1, so we can't actually do anything with that. So we're going to move on to step number 3. So step number 3 says to determine the value that is to be added to each side of your equal sign. And to determine this, you take half of the b value. So that's the letter or the number connected with your x term. So you take half of that and then you square it. So be very careful. When you have an actual a value that is not 1, there's a certain process you have to go through. So very similar to what we did in chapter 3. If you have an a value, in order to add it to the other side of your equation, you'd first have to multiply with that a value. We did something very similar in chapter 3. So just follow those steps there, okay? So in order to determine this number, you're going to take half of that b value, then you square it. So in this case here, we're going to be looking at 18. So we'll take half of 18 and then square it. So 18 divided by 2 is 9. So you have 9 squared. That's equal to 81. So what you're going to do is you're going to add it to each side. So that step there is a little bit different from what we did with quadratic functions. So what we'll have here is a squared plus 18a plus 81 is equal to negative 32 plus 81. So we're adding this term to each side of that equation. So before we move on to step number 4, I'm first going to simplify this right-hand side here. So we have a squared plus 18a plus 81. That's equal to, so it's negative 32 plus 81. That should give you 49. Then what we're going to do is we're going to rewrite the perfect trinomial as a binomial. Okay? So if you guys remember that trick from what I showed you in chapter 3, you take the square root of your first value, or your first term, which is, so square root of a squared is just a. Then on the other side of your brackets, you'll have the square root of your last term, which is 9. And then the symbol that is in between, so that is that b value, you're going to just write it below. So you have a plus 9. And when you're done writing this, then you have to square it to make it a square binomial. Then rewrite the rest of your equation. Then what we can do is, if there was an a value, you would divide it on each side to make this binomial by itself. In this case here, we do not have an a value, so we can go ahead and skip that step. So then moving on to step number 6, we're going to solve for x by square rooting each side. So essentially what we're going to do is we're going to get rid of this square, and we're going to be able to solve for a then. So we're going to take the square root of each side. That's going to cancel that square there. So we're left with a plus 9 on your left side and on your right side. And this step here is very important. When you taking the square root, you could have either a positive or negative value, and you don't know which one, so you have to state plus or minus 7. So just to reiterate, say if we're to work backwards, so the backwards of a square root is a square. So I'm just going to write this over here. If you look at 7 squared, that would give you 49. And say you looked at negative 7 squared, that would also give you 49. So if you were to work backwards and take the square root, well, how do you know if you're taking the positive value or that negative value? That's why we have to write plus or minus 7. So then in order to solve this, what we have to do is we have to break this up into two little scenarios. So what happens if 7 was positive, and what happens if it were negative? So we're going to rewrite this equation. So 8 plus 9 is equal to, and the first time you're going to take positive 7, and in the second little scenario, we're going to have we have negative 7. And then we're going to solve for a. So to solve for a, in our first little example here, we're going to subtract 9 on each side. So we get a is equal to negative 2. And same thing with our second scenario, we're going to subtract 9 on each side, but in this case we'll get negative 16. So a is equal to negative 2 and a is equal to negative 16 are the two solutions to this equation. Now to make sure we did our math right, we always have to make sure we verify it. So even if I don't ask you to verify it, it's really good practice to verify to make sure we did the math right. So that is step number 7. So we're going to verify those solutions. So in our first case, we had a was equal to negative 2. And then in our second case, we had a was equal to negative 16. So in order to verify, we're going to do exactly what we did in our previous lesson. And we're just going to plug in our a value, a is equal to negative 2, into our equation. So every time we see a, we're going to put negative 2 in there instead. So the original equation there was a squared, so we're going to write negative 2 squared, plus 18 times a, so 18 times negative 2, plus 32 is equal to 0. So we're going to simplify this left-hand side and show that it equals 0. So negative 2 squared is positive 4, 18 times negative 2 is negative 36, and then plus 32, and that should all equal 0 if we did our math right. So now we can go ahead and do our adding and subtracting. So we have 4 minus 36, which is negative 32, plus 32 would give us 0. So 0 is equal to 0, so a is equal to negative 2 is a solution to this equation. Now let's check our second one. So every time you see a, you're going to put in negative 16 instead. So you have negative 16 squared plus 18 times negative 16 plus 32 is equal to 0. So negative 16 squared is 256 plus 18 times negative 16 is negative 288 plus 32 is equal to 0. So let's check our math. Let's do our adding and subtracting. So 256 minus 288 is negative 32, plus 32 is equal to 0. So 0 is equal to 0, and you have verified both of your answers work and they are solutions to your equation. So that concludes everything for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.